4.4 is on a couple other ways to prove triangles are congruent. So what we're basically going to answer is explain how to show triangles are congruent other than using side, side, side. So we're going to learn a couple other methods. Definitions. The legs of a right triangle. In a right triangle, the side adjacent to the right angle is called the leg of the right triangle. So I draw a little picture. So here's a right triangle. There are two legs. Leg, and over here is another leg. So there's two legs. And the hypotenuse is in a right triangle, the side that's opposite of the right angle. So this is called the hypotenuse. It's the side opposite, I didn't spell that right. The side opposite the right angle. And I'll highlight it. This green highlighted side is the hypotenuse, and the other two sides are called the leg. Okay, so it's important we know that hypotenuse is the biggest side, and it's opposite the right angle. So the first postulate we're going to talk about is side angle side postulate. Which is SAS, right? Side, side, side was SSS. And now we're going to talk about side angle side, which is SAS. Okay, so I'm going to mark this up to show you what it would look like if it were side angle side. If it were side angle side, you would need one pair of sides congruent, and a second pair of sides would be congruent, so like this. So if it was marked like this would be the SS part, the two sides part. We're missing the angle right now. So for this to be SAS, you would have to have the included angle or the angle that's in between the two sides. So it'd be like the angle in between the two sides here and the angle in between the two sides there. So it has to look like that. So I use my highlighter. It would be, you have your sides marked. So you see all those two red sides? Notice the angle that's marked is the angle that's in between the two sides that are marked. Okay, that's what SAS is. It's the angle that's in between the two sides we know are congruent. Okay, and then we make a congruent statement here. Okay, somebody go ahead and name the first triangle. How would you name that? And the triangle on the left? Okay, so ASH would work. Now, if you match up the corresponding sides, what's congruent to AS?
JR.
So it would be JR. So it would be JRN. Okay, and order matters. So you could say ASH congruent to JRN, or I'm just going to show you a second way you could say it. You could say SAH congruent to RJN. Both of those are correct. So I just want to show you there's more than one way to write the congruent statement. Okay, and we're not going to do a lot of proofs, but there's one proof down here, kind of a mini proof. It says, write a proof to show that the two triangles are congruent. So you would start with your T-chart. What is the first thing you always start with for proofs?
What is given?
What is given? So we're going to start with segment JN is congruent to segment LN, and segment KN is congruent to segment MN. and that is given. So if we were to mark that in our picture, it would be JN congruent to LN, those two blue lines, and it'd be KN congruent to MN. So far what we know is congruent is there's two segments, right? Two sides. So that gives us like an S and a S. So far we know there is side, 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 or side, angle, side. Is there anything, if you look at that picture, that you could say is congruent based on the picture? Any sides or angles?
Besides JN and NL, no. Like, you can't say that JK is congruent to L.
Right. So we can't say JK is congruent to LM. Are there any angles that we know are congruent?
Yeah, angle 1 and angle 2.
Angle 1 is congruent to angle 2, and why is that?
Because JN is congruent to NL, and MN is congruent to KN.
The reason we know they're congruent is actually because what kind of angles are those?
Vertical.
Vertical. So those are vertical angles. So vertical angles are congruent. That's what we know from earlier this year. So we can say angle 1 is congruent to angle 2 because of vertical angles. It has nothing to do with the side lengths. We just know that those are congruent because they're vertical. But now if you look at the picture, do we have enough information to say that the two triangles are congruent? Do we have side, 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 or side, angle, side? Do we have one of those? Do we have two sides in one triangle congruent to two sides in another, and then the angle in between them is congruent?
Yeah.
So this would be side, angle, side, because the two blue sides and the two red sides are congruent, and then the angles in between them are. So now our last step would be, we would say triangle JKN is congruent to triangle LMN, and the reason would be side, angle, side congruence. So we can show that the triangles are congruent by side, angle, side. Okay. Example 2. Is triangle DMY congruent to triangle BMY? If so, justify it. So let's check the sides. We're gonna do this, we gotta check the sides. Is DM and BM, are those equal? So DM and BM, are those equal?
Yeah.
Yes. Okay. What about, let's check the next sides. How about MY? Is MY equal to MY?
Yeah.
Yes. So we have two sides. What else is given to us?
YD and YB.
So YD and YB, we could check to see if it's side, side, side. But we don't know if those are actually congruent. We don't know about, so you're saying about this side and this side. We actually don't know because they're not marked. The reason we know the red lines are congruent is because they're both 10. And the reason we know the blue line is the same in both is because the blue line is the reflexive property. MY and MY are the same line. But look at the yellow angles. Those angles are congruent. So what we actually have is, we have a side, an angle, and a side in both of these. So this is actually side, angle, side. So are they congruent? Yes, by side, angle, side congruence. So we know they're congruent because of side, angle, side. All right, so number 2 says, what can you conclude about AC and segment BD? So we're looking at what can we conclude about these two segments. And I'm actually going to talk through this one. If you look at the triangles, okay, if you look at these, we have one side congruent. AF is congruent to BF. We have one angle congruent. Angle F is congruent to angle E. And then we have a second side congruent. You can see that yellow side. So we actually have side angle side congruence here. So we would write down is, what can we conclude? We would say, all right, well, triangle AFC is congruent to triangle BED by side angle side. So we know that those two triangles are congruent by side angle side. It kind of shows in the picture, the red sides, the yellow sides, and that blue angle. If those triangles are congruent, what can you say about the two green parts? Well, go ahead, Gabe.
That they're also congruent if
So-
both triangles.
So if the triangles are congruent, we know that all the corresponding sides are congruent. So we could say, all right, well, CA is congruent to BD. Actually, I don't want to confuse you. It actually says AC. So AC is congruent to BD because they are corresponding. So since they're corresponding, we know that they're equal to each other because the two triangles are congruent. And that one made you think a little deeper than just trying to say, are they congruent? It's okay, they're congruent. What can we say about them? Okay, our last theorem from this section is hypotenuse leg theorem, which we call HL. HL theorem. So we're adding another one now. We had side, side, side. We just talked about side angle side. Now we have hypotenuse leg. One thing to note, hypotenuse leg only works when it's a right triangle. If it's not a right triangle, you can't do hypotenuse leg. So for example, a hypotenuse leg theorem says that if they're right triangles and both hypotenuses are congruent and one of the legs are congruent, then the triangles are congruent. So if you look in the example, those are both right triangles. If you look at the example, these red sides are legs. So I'm going to put an L for leg. The blue sides, do you see how those blue sides are across from the right angle? They're opposite the right angle. So those blue sides are the hypotenuse. That's the H part. So what we have is, we have right triangles, we have one pair of legs that are congruent, and the hypotenuses are congruent. So therefore, the triangles are congruent by hypotenuse leg. So our congruent statement is triangle, and let's call this one, we'll call it ABC. Is congruent to triangle blank. So what matches up with ABC? How would you order the second triangle? Well, you got to make sure B has to match up with X. So X would definitely go in the middle. And you got to decide what matches up with that red line. The red line is AB. The other red line is ZX. So AB and ZX have to match up. So it'll be ABC congruent to triangle ZXY. Because you're matching up the corresponding sides and angles. So the right angles match up, and those two red sides match up, and the blue sides match up. This has hypotenuse leg. Right triangles, and we got to show that a hypotenuse is congruent and one of the legs are congruent. So example 3 says to write a proof. I know we're doing another proof. Like I said, we're not going to do a lot on quizzes and tests. We're just going to do a couple together in class. So the proofs, we said you always start with the given. So we would start with saying AC congruent to EC. We would also say that segment AB is perpendicular to segment BD. Segment ED is perpendicular to segment BD. We would say segment AC is a bisector of segment BD. So we would have to list all of this stuff in the first statement, and that is given. That is what they told us is true. It's given. Okay, and in the picture, they have AC and EC marked. Okay, what I want you to think about is, what does this mean when they say it's perpendicular to? What does that mean if something's perpendicular?
Forms a right angle.
It forms a right angle. So what that means is, if AB is perpendicular to BD, that means there's a right angle right there. And if ED is perpendicular to BD, there's a right angle right there. So what we can say is angle B and angle D are right angles. And the reason is definition of perpendicular. We know from earlier this year that the definition of perpendicular means they form a right angle. So angle B and angle D are congruent, or they're both right angles. All right, next, what does bisector mean? It bisects BD.
It bisects it.
Which means
Go
it...
ahead and cut it in half.
Go ahead, and what?
It cuts it in half.
It cuts in half. So that means that AC cuts BD in half. That means, what we can say is, all right, well, that means BC is congruent to DC. And that is definition of bisector. It cuts in half, so it makes them congruent. So now if you look at the picture, we have right angles. So we have two right triangles. Okay, those blue lines, those blue two dash lines, are those hypotenuses or legs in the right triangle?
Hypotenuses.
Careful, those would be legs, the blue lines. The blue lines are legs because they're right next to the right angle. And these red lines, the red lines are actually the hypotenuses. So we have hypotenuses are congruent, and we have a leg in each that's congruent. So do we have enough to say the triangles are congruent? Yes. We can say that these triangles are congruent because of hypotenuse leg theorem. So our last statement is triangle ABC is congruent to triangle EDC by HL theorem. So the next 4 problems, I'm actually going to mark them and make them up as I go, and then you're going to tell me if we can, we're going to find out, can we show they're congruent or not? So like, let's do the first one like this. Okay, let's take a look at the first two. If these are marked like this, is there enough information in number 1 to say that those are congruent?
Yep.
Yes. Why are they congruent? What's our reasoning?
Because SAS, because it has two congruent lines in one angle that's the same.
Side, angle, side. We have a side, an angle, and another side. A side, an angle, and another side. So SAS. If you look at number 2, if it was marked like this, is there enough to show that these are congruent?
Nope.
No. We say no, and here's why. We have a side in each, right? Here's a side. And you'll also notice that they share a side. So we have a second side. But the reason why they don't work out is this angle right here and this angle over here. First of all, they're not congruent. And we don't know about the second angle over here. If that angle where that question mark was, if that was congruent, we could say they were congruent. But this one, can we say that they're congruent? No, there's not enough info. We can't make that statement based on our picture. Okay, number 2 or number 3. Let's go like this. Okay, if it's marked like that, so go ahead and mark your picture like that with your pencil. Can we say those triangles are congruent? If so, why? So let's check what we got. We have one side that's congruent. So we have an S. And we have one angle that's congruent. We have angle. Do we have any other sides that are congruent in both triangles?
Yeah, because the middle line, they share a side.
Yeah. When they share this side, that's actually another side that's congruent. So we have side, angle, side congruence. So it's yes, side, angle, side congruence. Okay, and then the last one, I'm going to mark this one up. Can we say those triangles are congruent?
Yes.
So if you look at these, we're actually thinking, okay, it's a right triangle. We're thinking, all right, hypotenuse leg. So we have a pair of legs.
Yeah, I thought the hypotenuse was like.
Okay, so it looks like the hypotenuse are, but we have a pair of legs. And you look at the other ones that are marked. This is a hypotenuse. And this is another leg. So actually, in these two triangles, they're not congruent. Okay, because we have hypotenuse leg in the left triangle, but on the right triangle, it's just two legs. So they're not congruent because we don't have enough info.